Hello.
So we should be live now. Hello.
Hello, Rajbir. How are you?
Good, Miguel. How are you?
Fine. Ready for another
Nice to see
webinar?
you.
Nice to see
Yeah,
you too.
this
Yeah.
time quite sooner than before.
Yeah.
We just did one last week. Yeah.
Yeah. But after the last webinar, I think we were discussing that this topic is quite interesting and we wanted to do something
Yeah.
with Omron. And
Yeah.
we are following more or less what we did last time, but today we are going to be working with Omron and discussing some how easy you can use the same model as we did, or the same model as we used the last time, but program it in another
Exactly.
environment, integrate it easily,
Right.
and for those that are not very familiar with PLC programming, and they have already understand that different manufacturers, they have different software and so on. I think they will be surprised how similar the PLC code can look like in different platforms as well. So we are going to discuss different topics today. But
And also how easy it is to integrate different drivers to our system.
yeah, yeah,
Like
yeah.
just using a drop-down menu, you can change the drivers.
Hmm.
So interesting to
So
explore that.
So just as a sneak peek, what we are seeing in the screen
Hmm.
now is the same system as the last webinar. This washing machine that is picking
Right.
and placing the parts with the portal, and then once they are washed, is removing them. But this
Hmm.
time we are playing with the Sysmac Studio, Omron Sysmac Studio, and their
Okay.
simulator.
Okay.
So we're going through the implementation, some nice features in Sysmac Studio. We really like the Omron platform, and we already had a webinar about Sysmac Studio and the
Right.
integration before. So this is gonna be kind of a complement.
Okay.
Yeah, and this time we are having the axis. Also, that's something
That's true.
it was new. We were in contact with Onron. We get some inspiration from them how to start and with the programming and so on.
Hmm.
You did the programming, and
Hmm.
we are gonna mention how easy you actually reuse code.
Yeah.
So this
Okay.
is this is basically what we are gonna be discussing today. Um,
Okay.
hmm,
I would be interesting to know your connection with Omron. How did you start it? I think you have some
yeah, yeah.
projects years ago.
Yeah, and this is the thing is that after this the webinar last week,
Okay.
I was looking around some videos I had in my
Okay.
hard drive, and I found
Okay.
actually this video we are seeing now is 20 years old, at
Wow.
least. I think at least 20 years old,
Okay.
and this is the
Crazy.
first emulation software I created, uh,
Wow.
and it was
20 years.
yeah, and it was with
Crazy.
Omron. You see, it's quite simple, but it was super functional. We could do quite big
It is.
stuff.
It is complex. It doesn't look simple. I mean, you have
No,
so many conveyors and racks.
yeah, but you see the models. It was cool because by then I was
Okay.
starting with the 3D engines and physics engine. By then it was another physics engine I was using, and all this was
Okay.
programming Delphi actually.
Delphi. Okay.
But you see the models are basically cubes, putting
Yeah.
together cubes and cylinders, and that was the 3D.
Okay.
But it was functional. It was doing the trick. We have some, as you see, some buttons and so on.
Hmm. Hmm.
It was a lot of. By then, I was working in this company doing automated warehouses, so it was a lot
Okay.
of logistics, both
Wow.
pallets and boxes. They have this mesh system, which was connected to the PLC. Everything could be tested against the virtual
Wow.
environment. So it was pretty cool. And as you see there, pallets could
Yeah.
get stuck or
All right.
whatever, and you could
Hmm.
uh, correct them. It was simple, but it's cool to see that the technology was there by
True.
then, and it hasn't evolved that much. We could say, of course, now with Simumatik platform, it's way more flexible. We can do more advanced
Yeah.
stuff, and we
Yeah.
have built. amazing machines with the Simumatik. I have to say that logistics is the easiest thing to model. I mean, because just basically you are doing conveyors and moving surfaces and so on. So it wasn't that challenging. Now when we are building these kind of machines with a lot of axes and so on, it's another stuff.
Okay.
But it was cool, and another, and that's why I kind of thought about Omron, because by then I was working mainly with Omron. It was mainly actually the first PLC integration driver I programmed. It was Omron FINS protocol to connect to real, the FINS protocol to connect to real CPUs. And we can mention that this driver is already published and in production in the gateway. So we will see later that today we will be using the Sysmac Studio simulator driver, but we could have deployed this code to a CPU, real CPU, and use the FINS protocol and run hardware in the loop. Yeah.
Oh wow. Okay, that's cool. So FINS is more like Siemens has Profinet, Omron has FINS.
Yeah,
like
the Ethernet IP for Rockwell. I mean, the different, or ADS for Beckhoff is their native protocol.
Native protocols.
And they have the UDP and TCP variant, and it's pretty well documented. It was by then I remember that it took us quite a lot of time to implement the driver in Delphi, but now with the gateway in Python, there are a few libraries out there, and it was super easy to implement, and we can read and write any variable in the PLC. So
and I can see in your video you call this Simulator, the software.
Yeah, simulator. It was in Spanish. Yeah.
Okay. Now it's Simumatik. So Simu is like the keyword you have it.
Yeah, exactly.
Cool.
Yeah. So this is the model. We can see it running now. We are gonna check the Sysmac Studio project soon, but just to mention basically what we did, or mainly you did, is to take the system that we already published some week ago, which is this Pick and Place Gantry. You did a clone, and this clone
I did a clone.
Yeah, just to change some parameters that we will check now and save them. So we have a specific project where we all actually have saved the PLC program and so on. This is our own private, but anyone can do that with a license. They can, if they want to save the progress, they can do what I'm gonna show now, and they can create the clone. Yeah. So basically, what needs to be changed, and this is kind of the fancy part in Simumatik, is that you can just take one model that maybe has been configured to use against a specific PLC and just make a few changes, and you can have it running for another PLC. And in this case, we did a connection to the Bosch Rexroth PLC, codices based with OPC UA. Now we just change in the PLC and the drives. We just change the driver to Omron next socket, which is the one that we need to use against the soft PLC or the simulator. And as we can see here, we have also the Omron FINS, which if we check the documentation, we will see that in that case, in order to get read and write variables in the PLC, you need to use the addresses. So it's different memory areas, and it's just check the documentation as usual in the manual, and you will see you can read different areas, and it's basically like we do with IW0 or whatever. Is the same standard. So different areas have different letters, and then if it's a word, if it's a byte, or whatever. The nice thing with Next Socket is that we use variable names from the global variable list, for example, or local variable list, which make things more intuitive. So we change these. We have the default parameters, which mean that we have the simulator in our own computer. That's all.
Right.
we changed this in the PLC, we changed this in the drives, and that was everything you did to allow the communication. Then of course we need to connect to the specific variables, and we can take that directly, what we did in the previous webinar as well, when we talk about integration with the Sysmac Studio. For the inputs and output, it is super intuitive, because you just added the hardware here, input cards and output cards, and basically what you do is you set a name to each input and output card. We see here input 1, input 2, output 1, output 2, and so on, and is the variables we use in Simumatik for each of the card. So here you see input card 1 is gonna read the inputs 1 variable, and so on. So it was super easy, and this is what we have in the other webinar. Maybe we can link in the comments if someone wants to know more about the integration. In the comments of this webinar, we can link to that webinar we had.
Maybe you can also show the panel where they can see the I/O cards in Simumatik, if it's easy for you. And they can relate why we took this input-output cards.
So here we have
these are the cards.
Here are the cards, and we can see them blinking and so on, depending the variables coming. Actually, now when we are online, we can see the values here in hexadecimal, and these are the bits that we can see here. This is bit 1, port 1, output 1 active. We can see it's actually mirroring and connected with a really good latency between the PLC and Simumatik. So that is something that we already did before, but we really like Omron, and we get in touch with their support department and the R&D department, and we say we want to program this with Sysmac Studio. We got an example how to control the axis, and basically it wasn't very difficult for you to add the hardware. Here we see that we have a motion group, and here you add the 4 axes, because as you remember from the previous webinar, this portal has 4 axes, X, Y, Z, and then we can also control, which we haven't used yet, but we can control the gripper with rotation in the Z axis. So it was adding this axis, doing some simple setup, I guess the limits and so on.
Just the limits and units. And maybe you can also mention, before we come to axis, we also install some drives. If you go on the Ethernet on top, you will see that 4 drives, hardware drives, are added. And these are linked to individual axes.
And this is actually, you were mentioning before, that we can see this communication actually being kind of simulated, even if we are in we are in simulator mode. We are running against the simulation. So basically, I just click play here in the simulation. We are running everything without any hardware. But the EtherCAT, it looks like the EtherCAT is kind of being simulated.
It seems like that.
So
I mean, it also works with the soft or virtual drives. You can take inside that as well. But I speak to the Omron guys. They said, no, you can use a real hardware in the configuration for the IO access.
And this is cool, because as we have seen with the IO mapping, we have the hardware configuration that is gonna be the same as in the real system. Basically, we are testing our, not just the code, but even the hardware configuration against the Simumatik. And I will say this, if we will have the real system, we could almost download the program as it is and have it up and running. So it's pretty cool, because you test even the hardware configuration and so on. So we have been investigating as well closing the loop for the axis. We will take it later, which is a quite interesting topic. They are also interested in the Omron R&D department, how we can not just send the set point of each axis or read the set point of each axis in Simumatik and reproduce the trajectories, but also close the loop, getting the encoder value from the model and seeing if we can make these drives detect, for example, that the axis has crashed or is gliding or whatever. It's kind of an advanced feature, but we have some tips from or ideas from the R&D department. We are going to show. We haven't been able to fix it, but it's something that we will be trying, and we are going to show basically what some ideas we got we can explore somehow. Like in most, or I would say all of the platforms we have been playing around, when you run the PLC code in simulation mode, it happens like here. The EtherCAD or whatever is simulated, and the axis act like ideal axis. So basically, when you use the move absolute functions and so on, they will generate a trajectory, and the set point position and the actual position will be similar. Which is good because it simplifies a lot, but kind of hides some issues you may have in the real system, because sometimes you have done bad configurations or in the drive, or maybe you have a crash. Your PLC code won't see that crash, and this is why somehow we need to disable that default feature where everything is ideal and try to close the loop. It's kind of a challenge, because I don't think many people is doing that, but I think it's the future to be able to test 100% of your project. Doing the real virtual commissioning.
And I would like to add that in Simumatik, we have some joint sensors which are sending the feedback value, and this we can use it in Omron. Although we have a tiny example, maybe you can show in the end of this data trace, where I try to show the feedback. So you can also see it here, for example, for x-axis. So it is getting the set point from Omron, and then Simumatik is giving a feedback, which we can use in the software.
So we see here two values. One is the set point coming or going to the mechanical axis, and the other one is the feedback where the axis actually is, and there is a delay, like in reality. I mean, we are telling the servo to move, but you have mechanical delays, you have gearbox, you have a lot of parameters that make that you are not ideally in the position as soon as you command it. So we can see it here, and we are actually both reading the set point, this one, and writing back the actual position in the model.
Exactly. Right.
And this is the loop that we are gonna check if we can close sometime. So basically the configuration in Simumatik was what we mentioned. We changed all the drive types to Omron X socket, default parameters, and then you created two variables for each drive, the set point position and the actual position. One is read from the PLC and the other is written with the PLC. And this is done 4 times. And then we have the PLC.
Maybe here, you can also mention in the drive, we have this relation parameter. I had to do it. This is default 1.0 when audience is using it. But I had to use it because in Omron I had a unit of millimeters, and in Simumatik we had meters. So you can easily convert this units using the relation parameters. So conveniently.
Yes, and this is something that the guys, when they did these generic drives, linear drives, they added these parameters. So you can read, if we take these variables, you can read the set point position, but as you say, maybe it's not exactly meters. So we can use this axis relation to convert it.
To convert it.
And then back the encoder. As I can see, you have been experimenting with the x-axis to see how we can close the loop, but not with the other axis.
No, not with others. I just wanted to try.
So here we can see that we are reading the set point from the PLC for all axes, but we are just sending the feedback or the encoder value for the x-axis. And that's basically all the configuration. So anyone that wants to reproduce what we did is just build a project in Sysmac Studio, add the hardware, create some global variables for the axis set points and so on, and then adding the units, the input and output units, and name them accordingly. Exactly. Yeah, at card name, or I think it's called, yeah, it's the card name.
I have mentioned the card name.
Channel name, or
yeah.
Because you can have, it's cool because you can have a name for each of the variable, which will be you can use then in the program. But just adding this name here makes it super easy to Simumatik to find, write, or read the entire card. Yeah. So that said, I think I can make a screen a bit bigger, and then I can move over.
I have one question before we continue. Like we are writing this variable to the cards, can we also connect to the global variable?
Yeah. Actually, that's the trick.
Actually, these are global variables.
Yeah, right? That's the thing. That's the thing with the when you add those names. If we go to the global variable list, I think we see them here. Yeah.
Okay, so
they create global variables. Yeah, and it actually addresses them to this card. So it's done automatically, and it's pretty cool because you go to the hardware configuration. You add the names to the cards, and automatically it generates these variables that you can easily use in Simumatik. And
that's cool.
If you check, I think it's documented in the driver documentation how you can even access local variables in Sysmac Studio.
Oh, cool.
Yeah.
Okay.
So you can access global variables and local variables in different POUs.
Okay, that's nice.
And here we see your set point variables, the actual position variable, those are real. And then we have these input and output cards. We see the axis, and then other variables that you created. The cool thing is that, thanks to the IEC standard, you did the programming in codices mostly in structured text. I told you probably you can copy paste the code and so on.
Yeah, I did that.
And you actually did that, and you mentioned we were talking about that before, and you say it was pretty easy. So copy paste.
This code is exactly copy paste with slight modification, and the variables I have to do manually one by one because the variable declaration here is not in ST. You have to do it like in a table.
You don't have another view here. Yeah.
I didn't find it.
Yeah, maybe we could ask them at Omron if there is another way to see the list. Yeah, I don't know. I know that they have
maybe importing.
Yeah, maybe
importing
or
could be that. Yeah, this I did not explore much.
Yeah, you can export. Anyway, is what I was mentioning in the beginning. People is always I hear quite a lot. I learn programming in this platform. I don't know, Siemens, Rockwell, Omron, whatever. Now I have another PLC and another from another manufacturer. How can I program it?
Yeah, true.
It's not that different. Since the IEC standard, I think most of the manufacturers are coming closer to the IEC standard. And the languages are defined. There are some rules. Of course, all of the manufacturers are not 100% compliant with the standard, but you can mostly, I would say, structured test is the easiest language to port because it's just text-based. The others are the diagrams and so on. I would say maybe it's not that easy, but the structured test, that's the benefit, that you can copy-paste it. And I will say you could move the structured test code from one platform to the other pretty easily nowadays.
Yeah, that's what I did. Because if you see another block, control block, or motion block. In motion block, I had to create blocks in ladder logic. So there's I couldn't copy paste. I have to do individually. So I can. It's just an example. If you make in ladder diagram or FBD, you have to do again in a different PLC. If it's structured text, you can easily copy paste, and makes your work easy.
Anyway, we can see we have MC power, we have MC reset, MC move absolute. If I don't remember wrong, it was the same names of the functions in codices. Those are standard function names. Yeah. So pretty cool to see that we could reduce most of the code and how long it took to you to program this and have it up and running in Omron. a few hours, I would say.
Right? Oh yeah, yesterday I tried at 4 o'clock I tried, and then I think in 3-4 hours I could do it. All the testing and integration with some bugs.
It was great. I mean, it's awesome that you can do it so quickly.
And it's also only because I had the structured text ready in codices. I just need to copy paste the sequence. Otherwise, writing a sequence is also big.
It takes more time. But it's pretty cool. So porting code, I think, is gonna become easier and easier between different platforms. We really like how easy it is to work in Sysmac Studio because everything is quite quick. You see now I'm online. I can see everything online, what's happening and so on. Accessing all the parts in the project are pretty easy. So basically, I don't think we need to go through the entire project, but you have this control part where you have the sequence and controlling the conveyor and different positions.
I can mention a little bit about control part. So when you see the Simumatik, the axis is going to some locations, right? These locations I tracked before, where is the best pick location and place location. And once I have this location data, basically you can do with jogging and find the best location. The jogging I had in the last webinar in Codices or with the control XPLC engineering. But here I did not do the jog. I did not add the jog parameter because I already have locations. So if you see in the control part, the step number 1 and step number 2 and 3, I have mentioned the locations. If you go a little bit down, control, there you can see starting with 0, 0, 0. And then if you go to next step and
here we have.
So you will see these are the numbers where I have to mention the location where it has to go for picking and placing. So you can notice I have multiplied with 100 because I had the location in meters in codices. I just need to add a gain of 1,000 to convert that into millimeter. So that's what it is happening. So all the recipe data or positions actually I have mentioned in this control block. And then if you go to the main block and the main POU,
I can make it this section. Sorry.
Yeah, we can make it this. This is a motion block. If you go to the main block, there I am exchanging the data between two function blocks. Control is sending the positions to the motion block, and motion block is sending the feedback to the control block. So when it reaches the position, it sends a done command, then control block says, okay, then go to next position. So they are just talking to each other in the main program. It's very simple.
Pretty cool to see here the name of the variables.
Yeah.
It's all the inputs and outputs, and the status and so on. Yeah, cool.
Yeah, super. It's not so difficult. I think it's a very easy code. People can use it. I can upload it in the asset. If somebody wants to have a reference, they can use it right away.
Yeah, and this is the motion as we were mentioning before, MC power, MC reset. I mean, typical stuff with axis, move absolute. You call in this, you are activating this from your sequence.
Right.
And then we're reading the actual position here.
Exactly. And this is giving us a parameter. If you see, this block, I have MC axis 00.act.pose in this block below this one.
Yeah.
This tiny block. This is where we get the real feedback, and I just convert that to real values.
Yeah.
Just changing the data set because I wanted to send it to Simumatik in real, not in LReal.
Exactly.
So that's why I have to do the conversion.
Yeah, there is something we need to fix in the driver because we didn't consider exchanging LReal variables, and we are gonna add that feature as well. So it was limited to just real. But
but it's okay.
Yeah.
In PLC it's much easier to convert, I believe, than doing it on.
So again, we are assuming now with this implementation that the virtual version of the axis is generating the trajectory. So we are using the actual position, which is the same as the set point position, in the axis, which is the one that is making the axis move in Simumatik. So we are running in open loop. What we want to investigate is if we can get the set point position instead and send that to Simumatik, and then get back or write in the virtual axis what we want to be the actual position, not the ideal actual position. And for that, we got the idea from Omron, the R&D department, that we could use this simulation set actual position. We haven't experimented. We haven't made it work yet.
Much. Yeah.
But I guess we need to disable the ideal axis calculation, and force the encoder position or the actual position with this function. So we will be doing these experiments. I think it can add an extra value to users working with Omron, so they can kind of close the loop. And that's all. I mean, it's not much more here. Then you have some error handling here, but this is the entire code, and
it's entire code.
Yeah, I mean, it's working without stop here. This morning as well. I have it for an hour or two, and it's just cleaning parts without a stop.
I mean, there is much more we can add to this diagram. We have an HMI feature in Omron, which I still want to explore. So maybe we can also add some jog function and move the axis to find new positions by the HMI. We can read the status. We can disable the drives. And if you further on want some analytics, we can also read how many products had been washed, how many products are not having some errors or failures, how much the failure drive had in between. So a lot more can be implemented on top. But I try to make some data trace for you. You already have the screen open. This is what you want to show. So here you can see two variables coming in. One is the actual position which motion block is giving, and one is the actual position from Simumatik. And if you click on this Y scaling, I think there is a button.
I think
it was this one. Then you can see how closely these variables are. So the orange one is what Simumatik is sending as a feedback, and the green one is the feedback from the motion block. So there you can also have a comparison between different axes and how they're moving.
And this is what we want, what we mentioned. If we can make the PLC believe that the actual position is the one coming from Simumatik instead, that you could actually see what happens if the axis crashes. Because the PLC will try to send the axis to a certain position, but maybe it crashes in Simumatik, it doesn't reach, the encoder won't reach the set point, and usually axes have this kind of error, following errors, that gliding or whatever, that could actually be triggered, and see what happens.
And we can also see if the axis is taking a lot of time to reach the set point. If there's a lot of delay, that could be a part of troubleshooting it. So we can see, okay, we have to fix that or something, or some triggering anomalies.
You see here is kind of stepping. And this is because the latency, we haven't spent much time improving the latency within the model. We can adjust some parameters if we need some more latency, but we are talking just about some milliseconds. So probably changing the RPI in the setup, we could get better latency. Because the model is running pretty smoothly, I think, in my computer.
Do you want to talk about this feature of graphics? Maybe, I think we didn't talk about it in any of the webinar. You can, if your computer is low graphical, you can
actually
change that. Maybe you can show it a little bit.
So I mean, I'm running in a quite nice computer. It's not very high end, but we are streaming everything now live and so on. But we are quite nice 60 FPS, which is what we are aiming for most of the time. We can, if you want to see how the model is performing, we can see. For example, here the physics engine is not having that much to do. 5-6% of the load is going wide. We can see here that the gateway is sending and receiving a lot of information, but this is expected. I mean, we really want to increase latency. So between the gateway and the workspace, we have 2 milliseconds latency, which doesn't mean we are exchanging data that quick between the PLC and the workspace, but we could go that quick if the driver allows it. Now, different drivers have their timing. So my experience with the Omron, this Omron driver, it was pretty quick. So probably we could change the parameters in the setup of the drivers and reduce the RPI maybe to 10 milliseconds and see even smaller steps in the graphs.
Okay.
So probably is doable. So and now I have quite nice numbers of these in the physics. In case you are running this in not such a well-performing computer, we have a settings parameter here since some weeks ago where you can reduce the resolution of the 3D.
That's very good.
And this
that is much needed.
Yeah, and it looks more ugly. You see, it's less resolution. Mostly when you are far away. When you come close, it looks good. It's just when you are far, it kind of looks foggy, or I don't know how to explain.
Less resolution.
Yeah, less resolution, but I mean it's moving well. In our case, it's not doing any performance impact. It's just mainly when you are running with integrated graphic cards, which require more RAM memory and even the CPU, because it's not enough with the GPU. You will give more room for the CPU to run the physics and the behaviors and the emulation itself. So it's quite recommended. And if you change that setting each time you start the app, it will keep it. So you don't need to be changing that setting all the time. And you can select between these three 175 and another thing that can be done as well is that we have a parameter here which is called force thread sleeping. I don't think we have mentioned it before, but this is
you can change my camera because my camera is on the parameter which you're showing.
I'm moving you. So I'm mentioning this parameter here in the settings.
Force thread sleep.
Yeah, and this is because we are running the model in multi-threading. We have the physics, the behavior, and so on. Everything is going parallel to optimize and be able to run as quick as possible. And the goal is to use as much CPU as possible to have a better emulation. But sometimes that means that depending how powerful your computer is, it's gonna eat up the entire computer. Mainly because, like now, I'm using the programming software. We are running this PLC in soft mode, which is actually executing the code in using our CPU and so on. And then we have these threads running the physics and so on. So it's kind of
going on.
I mean, streaming is going on. We are kind of demanding from the computer. If we are seeing that the CPU is being eaten up, we can put some sleep in here, and we will see automatically that the load is gonna decrease. It's not gonna make much in my case because already I don't have much load. But at least we have seen in the gateway, we were using 30%, and now we were back to 1.5. And if I leave it, we will see that it's going to increase again.
But does it change any? Does it has any effect on the performance?
Of course, but because what we are doing is we are trying to find moments where we don't have much to do. The emulation doesn't have much to do, and it kind of sleeps to leave room to other processes, which mean that we are not executing the emulation that often, which may have an impact in the latency, the quality of the physics, and so on. But it's a way that in some cases it's a trade-off. I don't have a powerful enough computer, but I want to run this. I don't care that much if I lose latency or whatever. I can change this. So I think let me see. I'm gonna remove the screen and go back to us. Let me place us in place. So I think we covered quite a lot. I don't know if there is something else we want to cover today.
Any other upcoming projects with Omron? Do we have something in pipeline?
Yeah, I mean, we want to test this HMI, as you mentioned. That is interesting. We would like to do more experiments with the real PLCs. So we have an old, I think it's a CJ CPU.
Do you have?
Yeah, we have and that's the one we use for for the communication with the fins. But we have some customers using Omron, and we are having quite a nice projects with them. So it's quite a lot of going on. We ourselves haven't been experimenting a lot, but now when we have tested the axis control and so on, I think we will be doing more stuff. It's quite interesting.
I also noticed while working on the Sysmac Studio, they also have a robot emulation.
Yes, and that is something that.
Have you tried that?
I haven't tried it, but somehow you can integrate quite easily the PLC and the robot, and this is something we want to investigate.
This I can also try. It's interesting. And any other future updates or features which we are planning?
The vision cameras or the 3D rendering in the workspace is already in testing. So we can actually now in the experiment environment, we can add components that have cameras, and these cameras will render what they are seeing in the workspace and be able to save it to files, stream them to build vision systems. So probably we will have a webinar about that during April, maybe.
Yeah. That's interesting. In the next webinar, we prefer to do this vision system or any other topic
maybe we can do that. You're taking vacation now for some weeks.
Vacation?
But we may make another. Maybe while you are on vacation, we will make another webinar with another topic. Maybe the new features in the workspace, because we are about to launch a new version of the launcher with some cool features that will allow connect the app to workspaces in another computer, which is pretty cool. So we will be able now. We are able to, with the new launcher in our experimental environment, we can run the entire model, the workspace and everything in a computer just dedicated for emulation, and then use a laptop just to connect to that and control the model. So that's interesting because in some cases we have some customers that have pretty heavy models, and we want to separate the emulation from the engineering tools, programming PLC and so on. And that will allow us to have different combination of having the workspace in one computer, even the gateway in another computer, or both in the same but not your computer, and so on. So it's going to be interesting.
That's nice. So is it only on the local network, or can it also be via web? So if someone want to have one demo in some, I don't know, in a webinar, they want to show a demo of their 3D environment and it's connected to a different country. Is it also possible?
Yeah, with the online workspace, you can do that nowadays. You can invite people from your organization to join the online workspace, but this feature is going to be to allow having the IP address. If you can reach the IP address of the computer having the workspace, then you will be able to connect to that. In theory, if you have a public IP for a computer in Germany, I could connect to that from my.
You can connect to that. Yeah. I can also use, I think, some tunneling software like NGRock to make a tunnel, and then you can connect. This is something interesting. I think this will be a nice webinar for the next months. So also, I would like to have a webinar on ROS, which we were talking about, because ROS we did not cover in any of the webinars. Also a very interesting feature we can talk about in the next months.
Yeah, and these things we are doing with the vision cameras, we are quite related to ROS as well. So probably there will be, or not probably, there will be a connection between these cameras in the components and ROS, but there will be other streaming possibilities that are more open, so you can build your own vision system in Python or whatever. But we are going to have a ROS webinar with robotics soon as well.
Yeah, that's on robotics school. All right, I think that was pretty interesting things coming up for the next months.
Yeah.
And
so
for audience who are watching, stay subscribed, follow us on LinkedIn. I think we'll be posting many updates.
Yeah, and if there is someone in the audience is interested in a specific topic, or maybe developing further any of the webinars we have had before, just write a comment, and we will try to fix it. Yeah.
Yeah. And we can also do a webinar with the audience if someone wants to show their platform, what they did before. We can maybe have an open vote.
Yeah, so for this webinar, we put in the comments a link to the previous webinar with Sysmac Studio. Also information if we are going to upload the PLC project, if someone wants to take it from where we leave it and develop further. And as always, we are very happy to get emails and information from our users that have done challenges or developed further. And as we mentioned in the last webinar, this washing machine can be developed and could handle several products at the same time and so on. So if someone wants to share their experience and share how they program it, we will be happy to show it in a webinar as well.
Yeah, that's totally true. I think this system has a lot of capabilities. And making some dashboard analytics would be an interesting way to explore it more.
Cool. But thank you, Raspir, it was a pleasure as always. I hope
thank you,
the audience enjoy it, and see you next time.